Yeah. So we start now the concept of let's say, should I talk you about the plane or we just jump to the angle?
Um, Can we just jump to the angle, if that's fine with you?
Yes, yes. Right, right. It will be better because yes. Okay. So let me define the concept of angle. This is very, very much fundamental and different kind of object in geometry. So here it is. So angle, you know, we'll learn here the angle and how to measure the angle. Okay. So
Uh,
angle mean yes. So let me write here. It consists. So angle. So let me write here the first the angle, a picture. So maybe this kind of thing. So let me here put A. Here put the name. The point. You can say the B, and here you can put the point C. Let's say, and here the ray. Here you have the ray. We have this picture, and this kind of picture we called angle. So how we write mathematical this? See, to construct angle, we need two ray that intersect at a point A, or you can say the angle consist consist of two ray which share a common point. Okay, so the common point is here A, and we have two ray. For example, here the rays are, so here we have the two ray. The rays are basically here A to B, that direction, and another ray is A to C, right? So here the common
yeah.
point, yes. So the common point is here the point A. Okay, Mohammed, right?
Yeah.
Okay, yes. So this actually we want this turn. How much turn you have here? So this we call the angle. Although there is one more turn, so this turn we not take this turn. We take the interior turn. Okay, you know maybe some people can take this one, but we not take this one. This is not taking, not take. Got it? We take the interior
Yeah.
turn. Yes, that we basically want to say the angle, right? So to define the angle, we need two ray, and those two ray will share a common point. Then the picture we get called the angle. See, now let me tell you about the name, how you give the name of a angle. So angle basically you can denote by, you can take the, you have to take 3 points, you know. So here for this angle, we name it by. So you have to take the common point in the as a middle term. Then you put here PC, this notation, or you can put here, always you have to take A as in the middle, so you can put CB and then this notation. Okay, this is for the angle notation, this notation. Okay, Mohammed, clear? So the,
Yes.
yes, important thing that, always we took here the, the common point in middle is in middle, right? So that is important, yes, whenever you write the angles. Okay, this is called the vertex. A called the vertex, yes, of the angle, and these two ray we call the sides of the angle. Okay, Muhammad, those are the name. for angle. So angle mean, you know, two ray start from one common point. Then the picture we get, we called angle. So the two sides, I mean two ray, we call the sides of the angle, and the common point that share by two ray called the vertex. Okay, and we denote the angle like this. Should I ask a question? If I put here, let's say you have the angle, let's say O here, and here you have this, and let's say here you have another ray, this. Let me put here the A point, and here let me put here B point, and here let me put C. Can you give me two different name of this angle? Can you give me two different name of this angle?
Um,
Hmm.
there is OB.
No, not OB. O you have to take middle. See how I put the name for this angle.
Oh, sorry. BO.
B O and A, right? So this means from
Yeah.
B to O to A. Then angle symbol. Yes. Then another.
Another one could be AOB.
All right. One more name. Can you give the same angle?
Um, COB.
Yes. Yes. COB. All right. Same angle. Because yeah. Right. One more name. BOC. Right.
Yeah.
Yeah, that way you can give the name. So here if you put another point on this top ray, let's say M point, then you can put more name. MOC, you can put MOA. So the thing that we maintain here, just the vertex, we have to take the middle. This is the vertex that we never mistake, right?
Yes.
The vertex is fixed. Yes, the only the point and point we can change, right? Okay. Okay, okay, right. Now, sometime you know what we need, that angle could be, formed by the segment. So you have just only the segment. You have here end point, let's say AB. Most of the time in geometry, you can see you have, you not take a ray, you just take the segment, which have the end point, let's say AB. Then how you put the name? Then you put name AO angle, the same thing, right? BOA. Okay, Mohammed, clear?
Yes.
Right, right. And now the question here, how you actually, see, any angle actually have two parts. One is interior part, other is exterior part, right?
Yes.
All right. So, for example, if we took here the angle, let's say this kind of angle, I put it here. So for this angle, this part, the green color, let's say I put here the green, this situation, this region, we call the interior. And let's say the outside, this part, for the angle, with respect to the angle, where you have the angle on the plane, it divide into two parts, interior, exterior. This is called exterior. So let's say you have a plane, on that plane you have a angle. This is the plane, let's say script P, and you have the angle called, here the point, let me put A, O and B, right? So then you have interior part of the angle, and you have the exterior part here. Okay, Mohammed, is clear? Got it?
Yeah, it is.
Very good, very good. So if you have a angle where you are working on a plane, then it has interior part and exterior part. All right. Now let me tell you the one example. So let's say I took here a point with respect to this angle. Now you tell me it is on interior or exterior. So let me take here the yellow color. So this point, can you see it? the point P, and here the point Q. So P point is in interior or exterior, Mohammed? P point for with respect to this angle.
Uh, uh, he is exterior.
Q point is interior point or exterior point?
Which Q?
This one here. Can you see the
Yeah, yeah. Q is interior.
interior? Okay, very good. Right, right. Okay, nice. So now, you know, now let me tell you the about the, see, I forget to tell you the middle point of a line segment. So, so the middle point here, little bit, let me tell you the middle point. I think in the previous lecture we had this middle point concept, right?
Yeah.
Okay, you did it, I think so, but I did not explain with you middle point of a line segment. Let me tell you one line about the middle point of line segment. See, if you take a line segment, let's say it has a finite length, let AB is a line segment. So middle point mean a point that lie on the line segment such that the length of this, are equal, right?
Yeah.
Yeah, that is the idea. Or you can say if you add these two line segment, if if you take two piece of line segment and join them at the point M, you get whole line segment AB, right? So this is, this is basically, geometrically what you are doing for this. For the first one, what you did, you have a line segment AB, then you select a point M such that the AM is the same as BM. So without break the line segment, you decide that measuring these two distance. But for this one, what you doing? Basically, you take a line segment and it break it at the point M, and then again you join at the point M, and then you can see that after join you still get the same, the segment AB. Got it, Muhammad?
Yes.
So that's the idea. Yes. Okay, okay. So basically, middle point always divide a line segment into two equal parts. Now I tell you one thing: a straight line or a line, if you take that line, cannot have a middle point, or ray cannot have middle point. Okay. So
Yeah.
yeah, because the line mean it is infinite length. It has infinite length. Also, ray mean it has infinite length, right? So then how you can find a point on it, that tell you that okay, this point divide into two part. It is not possible, right? Any point, for the line, if you take the line L, any point will be the middle point of the line, right, Muhammad?
Yeah.
Because it divide any point, because in the left hand side length, you know you don't know it is infinite, this side also infinite, and both that kind of infinite are equal. But for the segment, it is little bit different. If you look at segment, let's say O to, let's say this direction I called A. Now the point is, if you select here, is divide the whole ray into two part? No, right? This side is finite and this side is infinite, right?
Yeah.
So the ray cannot have any middle point. Only segment can have middle point. Also for the straight line, I mean line, there is no middle point unit. You got it? Muhammad, is clear?
Yes. Yeah. Yeah. Yeah.
Very good. Now same thing we do for the angle. Can we divide a angle into two parts? So that we see here. That is called, the angle addition postulate, something, whatever. So let me put it here. So in the next page. So any question about the angle, Muhammad? The angle name, interior, exterior.
No, I don't have any questions. I
Okay.
understand.
Very good. The name is very important. This way, you always put the vertex in middle, and you take the end point you take from the ray. Okay. Yes. So now go to the next is the this is very important, the angle addition postulate. So addition postulate. So it is something like, if you take a finite line segment and if you break it into the two part, then two part together, if you again join, get the line segment itself, right, Mama?
Yes.
Okay.
Yes.
Very good. That we write here as a postulate, because in mathematics we not allow the operation. I mean the breaking, and you cannot, you have allow, you can draw a line segment. You cannot take a line segment on your hand, and you cannot break it into the at some point. You have to do logical. So instead of doing physically, if you want to do logically, that situation you have to write using postulate. That I'm doing here. So let's say, yeah, you have a angle, something like that. Let's say here O point. Here I put a point A, and here we put a point B. So the given angle. So given that we have a given angle AOB. Okay, Mohammed.
Yeah.
Right. Now you take a interior point here. Maybe this is the interior point. So also given, so C is interior point. Interior. So now what we do? Now you have to take interior point. That is important. Now let's join, you know, draw a ray. Now that we draw here, the draw part. What we are drawing. So these are the given part. So draw a ray having endpoint O and passing through C point. Okay, so let's draw it. So end point is O and passing through C. So in the direction of C you have to draw. Right, Muhammad?
Yeah.
Yes. Then the postulate says, angle postulate, tell us that. So now how many angle we have now? Total, you have two angle.
Three,
Yeah, three,
two.
exactly. Three. You are correct. Small two angle and the large angle, right? So we have angles. Let me write it here. So old angle, let me write here. Old one is basically AOP, and the new are basically here AOC, this angle, and BOC, this angle, right, Mama?
Yes.
Very good. Now what is the relation that given by the angle postulates? So this is the, by angle addition postulate, what we get. So angle addition postulate says that if you take these two angle together, I mean AOC angle and BOC angle, if you add these two angle together, okay, first you take having OC, how we doing this, the add mean, let me tell you, this we are doing basically, take two angle, you know having OC common ray, right?
Yeah.
So then, yeah, common ray. So this is plus that I put it here. Did you understand how you add two angle? Take two angle, and then this part. the OC. How we decide through which ray you add? You take the middle point and the point that having common in both angles. C point is the common in both angles. So you have to join through the OC ray. Did you understand, Muhammad?
Yes.
Then yes, you get the angle AB, AOB, AOB. So basically, the postulate, the angle postulates tell us that if you take any interior point and then if you make a ray to that interior point having n point, the previous for the angle and point, then that two angle if you add together or you cut it out from the plane and then if you put in the another place, then add join them through the OC segment human ray, then you get the same angle AOB. Measure will not change. Oh, okay, Muhammad.
Yeah.
Okay, that is the idea behind the angle addition postulate. Yes. Okay, nice. So let me tell you, the angle bisector definition. Now this, so where I write, should I write in the same page here?
Sure.
Okay. So what we have done so far, before go to the angle bisector, let me go through again, the thing we have done. We have defined angles, new geometric figure. Angle consists two ray and they share a common endpoint. So this kind of picture. So always we focus on the interior part, how much turn, and then give the name of a angle this way. Any angle have two things. One, it has vertex, and other thing the two sides that given by the ray. And when we give the name, we have to put the middle term of the name or middle letter will be the vertex, and the two sides letter are basically the letter we get from the rays. Okay,
Yeah.
in any direction, any way, any one of the ray we can select. Any, the point we can take from any one of the ray. It is not matter that you have to maintain that you have to take this ray first and that ray. Not necessary. You can take any ray, and select the end point. Then take the another ray, select the end point. I mean the a point on that ray, and then give the name. Okay. Now what we doing, like segment, if you take a straight line, we know if we take a straight line, we can break it into two parts. I mean, in if you take a point between the segment, then we can break through that point. Then if we took, that two part, if we took and place in the another, the place and join them by the break point, then you get back the same straight line segment, right? The same thing for the angle. This is the angle, addition postulates, right? So now let me tell you here the bisector, angle bisector. Any question, Muhammad, so far?
No, I understand.
Okay. So let me put here the angle bisector. Then I'll ask you a question because okay. So if you have this angle, let's say you have a angle OA and let's say B. So this is given. So given angle we have OAB. Now bisector mean a ray, of course the C will be the interior point. OC is called the bisector. How many bisector can have? I will tell you. Bisector of the angle AOB, if AOC angle is the same as BOC angle. Got it, Muhammad? If these two angles are same, yes, this angle is the same as this angle. Did you understand?
Yes.
Okay. So now the question here, how you check two angles same? So if I provide you two angle, let's say you don't know the measurement. So for example, if I give you two line segment, let's say it start from A and up at B, and I give you here another line segment C and D. So suppose Muhammad, I am not allowing you the ruler, not allow ruler, a ruler, or you can say the scale. So then without using ruler or scale, this is not allowed. Warning. So can you check these two line segments are equal or not? Which one is the bigger than other? So can you do it by physical? Is it possible? Any idea?
Sorry, could you repeat the question? I couldn't hear you.
Okay. I'm saying suppose we have two line segment A to B. So it has a length, right? We don't know because ruler is not allowed here. And C
Yeah.
to D. Yes. And the line segment we have. Now can you check which one is the bigger, or are both same length? Instead of using ruler, is it possible by hand?
No.
A little bit think you can do it. Just it cut it out from here. It is cut it out from here. This line segment, you can cut it, right?
Yeah.
And you have endpoint AB. Yes, put here the A endpoint. Then try to place it here on this line segment. If B coincident with D, then equal. If B is here, then less. If B is here, this three situation can be happened, right?
Yeah.
if if this situation happen, A to B, it coincident with D. So first job what you do, you take this line segment AB, cut it out from the plane. Can you do it? Yes, right? Cut it out
Yeah.
and put it here. The end point A put at the end point C. Then you put along this line segment CD, the AB line segment. If B coincident with D, they have the same length. If B is end before D, then it has the small length AB. If B is here, then AB has larger length. So that we can do, right, without using ruler scale. Got it?
Yeah.
The same thing. The angle, how you check two angle are equal. If you have two angle, let's say here a angle you have, and here if you have another angle. So how we can check these two angle equal? So what we do, we have to coincident. So this angle. So let's say O and let's say O dash. Let's say O, let me call here A, and let's say called here B. And this is called M, here N, and this is K, this is let's say L. Okay. Okay, Muhammad.
Yes.
Okay, how we check they are equal or not? First we take any one of the angle, cut it out from the plane. Let's say this angle we cut it out, this angle. And let's say try to put it here. So first we put here A point, and along BM we put the line AK, right?
Yes.
Now try to adjust AL with BN. So if it is here, so L, then small than the this one. If it is coincident with this, then equal. If it is here, then larger. Did you understand the concept?
Yeah.
That is the idea. But we not do this. We use the postulate. Then from there we can decide it. Okay, got it? Got it?
Yes.
Okay, very good. Right. So now let the angle bisector is this. So the I put here the equality. The equality, the angle, two angles are equal. So you can ask me a question, how we check two angle equal? Because there is no like ruler scale. We use the ruler to measure the line segment. Do we have any instrument that we can use to measure the angle? Did you understand? Have you seen ever
Yeah.
the instrument? What do you call that? That the instrument that used to measure angle. Have you seen?
A protractor. A protractor.
Projector, right? That projector. Now if I not allow you projector, then how you measure? Check two angle are equal or which is bigger than other. So you have to do this process, right?
Yes.
Okay, right. By the way, so you have the projector. We are lucky that we have projector already, so we can do it. But many day ago, people have no projector. They were doing like this and then developed the postulate process that we do. But I think you have clear concept on the angle bisector, right, Muhammad?
Yeah.
Now let me tell you the measurement of angle. Now we go to the last concept, that is measurement of angle. Measurement of angle. It is very nice. Like, see, if you have a line segment using ruler, you can measure it, right?
Yes.
Yes. So let me recall. If you have line segment, let's say AB, yes, you take the ruler, then you can measure it, right? Ruler you have already people construct, right? 1 2 3 4 and 5. 1 2 3 4 and 5. 1 2 3 4 and 5, like this. 1 2 3 4 and 5. You put it here. This is the ruler, and we can, or scale. So using this, we can measure the length of the line segment AB. Yes. So we have, now the question, how this was developed? This was, did you understand? When people, invent this ruler, they, they put here the marks, right? Right, Muhammad?
Yes.
So how they developed, there was a geometrical theory behind this development. I will not tell you. Similarly, how you measure angle, you need a projector. How the projector developed? So first we need the 1 degree we use basically. The unit will be degree. Okay.
Yeah.
So to measure angle, we use the concept of degree. Yes. Now there is a history about the degree. So it comes from the rotation. Okay. Because look at angle mean what, basically how much turn you took, right? Right, Muhammad?
Yeah.
So basically, see, if you think like this, that you have a fixed line segment and fixed ray OA, and another ray, let's say it turn around this. So maybe some place here, after some place it is here, and let's say after some place here, after some place here, after some place here, after some place here, right? So maybe some, so let's say you have here, after some place 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 you have here, like that. Okay, Muhammad?
Yes.
Okay. So, something, rotation, total complete full rotation is needed. So that time, ancient time, people actually observe the sun, right? We are living on Earth, right? And here we have sun. I'll tell you the degree, about the degree, how they develop. So then, if you someone stand here, you know, he think that, you know, the Earth total make complete around the sun. It took 360 day. Okay, sorry, yeah, 360 day approximately. That time people actually guess. Okay, so the Earth take 360 day to complete round around the sun. Okay, Muhammad?
Yes.
So on that base, they, actually developed the whatever you projector you have. The, projector has 1 degree, 2 degree, like this. How they divide? So let me tell you. See, let's say, so if you have ray OA, and if you make the total complete rotation and come to this ray again, you coincident, then total angle is, for full complete rotation, full complete rotation you know, total angle we get is defined by 360 degree, or shortly people write like this 360. Okay, Mohammed, okay?
Yes.
Right. Now, if we can develop a process of divide of angle, maybe then we can find out 1 degree, 2 degree like this. And yes, we have a process. How? So let's say that the ray you have OA, and you take the opposite ray, let's say this direction, having the common point B. If you take these two opposite ray, then this is the half rotation, right? Right, Muhammad?
Yeah.
So then half rotation mean, total angle 360, you have to divide it by 2. So this is 180 degree. So this is the straight angle, sometimes people call this angle called the straight angle. And the measure of the straight angle is 180 degree. Got it? So 180 degree angle mean it is nothing but, you know, it is a, you can say, collection of two opposite ray. So the two ray, you know sharing the common end point, then the angle we get, this angle basically is called the top angle. Basically normally people take is, the measure is 180 degree. Okay, Mohammed?
Yeah.
Now if we
Mm.
take a point, yes, C, and bisect it, then the angle we get here will be the half of the right angle, the straight angle. So this is 90 degree. So that way he could, the 90 degree developed. Okay. So normally, this way angles develop, and the projector developed. So basically the idea is, if we have this kind of thing here O, and then if you put here this, then this is 90 degree, right?
Yeah.
And the if you divide the total 90 degree, total divide 90 equal, so then the small part will be 1 degree. Got it, Mama? And we
Yeah.
have this way they develop. So we have the concept 1 degree, 2 degree, 90 degree, 180 degree. Any question, Muhammad, from here? Why they? Yes, any question?
No.
Okay. Why they took 360 degree for full complete rotation? Because of astronomy. Because they consider the earth took 360 days to complete a rotation around the sun. From there they motivated. Okay, and got it. Okay, now a question. Let me ask you a question here. Question. Okay, Muhammad? Hello.
Yeah.
A question. Let's say you have a angle RT, and here you have a angle RQ. This is the angle, okay? And you take the
Yeah.
interior S. So if,
Yeah.
yeah, the measure, so M mean measure, we write M mean measure QRS is 42 degree. It is given. So QRS is 42 degree. This is 42. Okay, Muhammad?
Yeah.
Okay. Now they asked,